misleading graphs. So these are kind of things to watch out for if you're making a graph, or if you're looking at a graph, things to watch out for. And according to data from the U.S. Census Bureau, in 2002, a U.S. dollar could only buy about half of what it could buy in 1980. So this graph is purported to show that the shrinking value of the dollar. That the does it look like the 2002 dollars? Does that look like it's about half the size of the 1980 dollar? And I think most people would say no. It is half the height, and it's also half the width. But the eye is drawn to area. So if you look at if you kind of look at the area, this is half the height, and so if you double the height, double the width, you're going to actually get be able to fit four of these dollars in here, right? It's half the height, half the width, but it's only 1/4 of the area. So it the eye is usually drawn to area, and yeah, most people would say that this dollar looks like it's a lot smaller than just half the size of the bigger dollar. So when you're making a graph, or when you're interpreting a graph, if it's a one variable graph, you should only be adjusting the graph in one dimension. You shouldn't go, this is the one variable, this is only the value of the dollar is one variable, and we're shrinking the graph in two different directions, the horizontally and vertically. So you're shrinking it in two different dimensions. So that's one thing to be careful about the graph. You want to only shrink it into in one direction for each variable. Okay, so another example of the declining value of the dollar. This graph here, on the vertical scale, is the value of the dollar in 1950. Dollars could buy a dollar's worth of goods, according to what the dollar was worth at that time. But then by the time 2000, it looks like it's compared to the 1980 dollar, it looks like it's maybe about 18 cents. It looks like it's under 20 cents, maybe about 18 cents worth of stuff in 2002. So anyway, this graph, it looks like the dollar value declined very steeply from 1950 until about 1990, and then it looks like it leveled out. After about 1990, it looks like it leveled out. And what is misleading about this graph? If you look at the scale here, the tick marks are every 10 years initially. So over a 10-year period, you're likely to see more of a decrease than you would over a 1-year period. On the right side of the graph, the tick marks are every 1 year. The value of the dollar might have leveled out, but it also might have been partly just the way they constructed the graph, that they scaled it differently on the right side than they did on the left side, so that made the graph misleading. Okay, another example of a graph that's even worse. This is actually the same data set, but it's worse because the labeling is not clear. This one, at least you could, example 2, at least you could see where they went wrong with the graph, because the labeling was pretty clear on this graph. This graph number 3, it's actually the same graph as the one before, but the labeling is not clear. This is series 3, whatever that means. Now this one is a bit more clear. This is the declining value of the dollar, and they have dollar signs on the left scale, and they have the years on the bottom scale. So that's the clear labeling. But this one here, it's the same data, series 3, whatever that means. And then we have these numbers at the bottom, 1, 2, 3, 4, 5, 6, 7, 8. We don't know what those mean. We have some decimals on the side. We don't know what those mean. This is both these. I made these graphs, both of these graphs, with using Excel, a spreadsheet, if you don't put labels into Excel will make up its own labels, which may not really mean much in terms of the data. So this one here, I actually inserted my own labels that was more meaningful. But anyway, that's another thing to be careful with graphs. You should whether you're making them or reading the graph should have clear labeling, so that it's easy to see what they're doing. Here's another example of a misleading graph, this is also about the declining value of the dollar. Here it says, so here we have 1980, we have a full dollar value here, and by 2010 it looks like it's I don't know, maybe 1/10 of what it was in 1980. This one here, the value of dollar, it goes up to 1 in 1980, but then it doesn't. It looks like that it doesn't go down as far. But these are for the same data. So why is, if you can look at the size of the 2010 bar for the first graph, it looks a lot shorter than the 2010 bar for the second graph. So why, if we're using the same data, would the graphs be so different? And the answer is, again, in the scale. This scale here on the left doesn't go all the way down to 0. It looks like it goes down to about 30. It's not labeled here, but if you can tell the same pattern here, if the tick marks, it looks like they're every 10 cents. So it looks like it goes down to about 30. So this is actually 2010. If you pay close attention to the scaling, it looks like it's almost 40 cents. And that's about the same as it is over here. It's about 40 cents, the height of this bar here. If you go across and read off the vertical scale, it's about 40 cents. But 40 cents on this scale, it looks like it really is 40 cents. It looks like it's about a little bit less than half the value of the 1980 dollar. But this one here, it looks like it's more like about 10 cents or something. But you have to, because the scale doesn't start at 0. So because the scale doesn't start at 0 here, then the bar here looks like it's a lot shorter than it really is. So anyway, those are some things to watch out for if you're either making a graph or interpreting a graph. And that concludes this presentation.